Traveling to the future isn't just science fiction. It's possible right now, according to Albert Einstein. The key is something called time dilation. Here's how it works. Time literally slows down for anything moving close to the speed of light, or for anything near an incredibly strong gravitational field like a black hole. So you could board a starship, accelerate to near light speed, and cruise for what feels like a few days to you. But when you return to Earth, you'd find that decades, maybe even centuries have passed. Everyone you knew would be long gone. This isn't just a wild theory. Astronauts on the International Space Station are already living it. Because of their speed and distance from Earth's gravity, they age just a few milliseconds less than the rest of us. It's a tiny glimpse, but it proves the principle is real. But what about traveling to the past? This is where things get weird and paradoxical. The most famous problem is the grandfather paradox. Imagine you go back in time and accidentally prevent your grandparents from ever meeting. If they never meet, you're never born. But if you were never born, how could you have gone back in time to stop them in the first place? It's a perfect, impossible loop. Physicists have a few ways out of this mess. One idea is the multiverse. When you change the past, you don't change your past. You just create a new branching timeline, a parallel universe, while your original one continues on, completely unaffected. Another is the self-consistency principle. You can go back, but you can't change a thing. Whatever you do was always a part of history. The ink is already dry. Then there's the block universe idea, which suggests that all of time, past, present, and future, exists simultaneously, like a frozen four-dimensional block. Your journey through it just creates the illusion of moving forward. To actually build a machine that could navigate this, we need some seriously exotic physics. We're talking about wormholes, hypothetical tunnels ripping through the fabric of space-time to connect two different points in time, or maybe cosmic strings and rotating black holes, structures so massive and dense they could theoretically warp space-time enough to loop back on itself. But so far, there's zero experimental evidence any of these cosmic shortcuts could actually work, or even exist in a stable form. Let's just imagine for a moment that we figure it out. We build the machine. What happens to us? The consequences are staggering. History would no longer be a fixed record, but a malleable script that could be rewritten or multiplied into an infinite number of variations. We'd need entirely new laws to deal with temporal crimes. Imagine prosecuting someone for altering a historical event for personal gain. Our very sense of self could dissolve. What would it mean to meet a younger version of yourself, or to see the different paths your life could have taken? Would you still be you? It's a concept that could shatter our understanding of cause and effect. The ability to travel through time might not just change our history, it might force us to confront the very nature of our reality, revealing whether our choices truly matter or if we're all just following a path that was written long ago.